Welcome to this unit known as construction material. Unit code is BCCE 703 and unit topic is cement. Let's start with cement. Cement is an important building material. It is commonly known as a binding material in some cases. It is manufactured either through natural stones or by artificial method. We've got natural cement, usually obtained by burning and crushing the stone, containing clay, carbonates of lime, and magnesia. The manufactured one, or rather the natural one, it is brown in color and has lesser strength. And a good example is Roman cement. We've got artificial cement. It is manufactured by burning a mixture of calcareous and argillaceous material at high temperature. Then the best example that I can give you, it is ordinary Portland cement. From this picture, you can see we've got three pictures. One of the pictures is the ordinary Portland cement. Then we've got the Portland slag cement. And the last picture is an application of how we can use cement. The other picture that you can see here, with a mixture whereby we are applying cement in making mortar, and the other one it is just a mortar in a trowel. The other one it is a ballast that we can use with cement plus sand to make concrete. Let's talk about property of cement. Cement should be an excellent building material. The first property, it should set early, and it should also have high strength. It should be easily workable. It should offer good resistance to moisture, and it should possess good plasticity. Let's talk about uses. Most commonly used in building material, it is used to prepare cement mortar. Cement mortar is used for masonry work and plastering, used to prepare cement concrete, used for laying floors, structural components such as beam, columns, lintel, etc., and also roof. You can also use it to make precast products such as slabs. You can use it to construct bridges, culvert dams, tunnels, roads, etc. We can also use it for special applications such as expansive soils. You can use it to repair cracks. Like white cement, we can use it for ornamental finishes, etc. Let's talk about composition of ordinary Portland cement, the OPC. OPC has two basic ingredients: the calcareous material, e.g. limestone, chalk. Then we've got the argillaceous material, e.g. Let's talk about the chemical composition of OPC. We've got lime. The symbol of lime, it is given there. The chemical symbol for lime, it is given there. And in OPC, we need it at around 62%. Then we've got silica. The symbol, it is given there, and it should be around 27%. We've got calcium sulfate. The symbol is given there and should be around 4%. We've got alumina. Symbol also is given there. Should be 5% in OPC. We've got iron oxide. Also symbol is here and should be around 3%. We've got magnesia. The symbol is given here and it is 2%. We've got also sulfur. Symbol it is given here and should be around 1%. Then the other chemical ingredient, it is alkalis and should be around 1%. Then let's talk about function of cement ingredients. The first ingredient that we have, it is lime. Its function is to impart strength and soundness to the cement. We've got also silica. It should impart strength due to formation of dicalcium and tricalcium silicate. We've got also alumina, which imparts strength quickly by setting property. We've got also calcium sulfate, who's present in the form of gypsum. It is present in form of gypsum, which increases the initial setting time of cement. We've got also iron oxide that imparts strength to cement. We've got magnesium, it imparts hardness and also give our OPC its color. We've got sulfur and alkalis, which imparts. Then let's talk about manufacture of cement. We've got two ways in which we can manufacture our cement. The first one, it is through wet process, and the second one, it is through dry process. Anytime we are manufacturing our cement, it has to undergo three steps, that is mixing of raw materials, burning, and also grinding. I've got a flowchart here which summarizes the dry process. As you can see, from one hand, we've got the calcareous material, like limestone. Then the other hand, we've got argillaceous material, like clay. So they'll have to, those two materials will have to undergo crushing all the way up to distribution, as my flow chart is showing. Let's talk about the chemical composition of OPC. We've got lime. The symbol of lime, it is given there. The chemical symbol for lime, it is given there. And in OPC, we need it at around 62%. Then we've got silica. The symbol, it is given there. And I want to remind you that raw materials in cement in these two processes will be limestone and clay. Let's talk about composition of ordinary Portland cement, the OPC. OPC has two basic ingredients, the calcareous material, e.g. limestone, chalk. Then we've got the argillaceous material, e.g. tanks. Then let's talk about burning. It is carried out in rotary kiln. The slurry is fed into rotary kiln and heated by using coal dust. Due to this, the slurry loses its moisture and forms into small lumps. The temperature is kept between 1500 to 1650. The lumps are converted into small hard stones, which we usually call them clinkers. The size of clinker varies between 5 to 10 millimeter. It is then cooled in clinkers and stored in containers. This picture that I have here, it's just a semi-storage chunk in a batch plant. Then let's talk about grinding. Cold clinker are ground in ball mills and tube mills. During grinding, 3 to 4% of gypsum is added to control the initial setting time of cement. Here, gypsum will be used as a retarder. The finely ground cement is stored and then weighed and packed. Let's talk about quality of good cement. The color of cement should be uniform. It should be of uniform fineness and free from lumps. Cement, if thrown in water, should sink. When tested in accordance with British BS specification, the average compressive strength of the cement at age of 3 days and 7 days should not be less than 11.5 MPa and 16 MPa respectively. The average tensile strength at the age of 3 and 7 days should not be less than 2 Newton per millimeter square and 2.5 Newton per millimeter square respectively. Initial setting time should be less than half an hour. Final setting time around 10 hours. Insoluble residue should be less than 1.5%. Magnesia content should be less than 5%. Expansion of cement should not be greater than 10 millimeter during soundness test. When the cement is sieved in 90 micron sieves, the residue should not exceed 10%. The presentation was done by George Obusiko. Thank you.